Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In this episode of Energy Talks, my guest is Juanita Dominguez. She is an OMICRON protection testing engineer based in Erlangen, Germany. Juanita studied electrical engineering in her native Colombia and talks about what made her decide to focus her attention on becoming a behind-the-scenes expert in protection testing. Juanita shares her passion and insights into the critical role of protection testing in electrical substations and also in helping customers meet their testing challenges in the field. Juanita also highlights memorable protection testing projects she has worked on and learned from, offers valuable tips for engineers who want to go into protection testing, and emphasizes the importance of providing product development teams with feedback about how protection testing devices are used in the field. Juanita also talks about the significance of protection testing in maintaining safety and reliability in power systems and what she considers to be important future trends. So without further delay, I welcome Juanita to this episode of Energy Talks. Hello, Juanita.
Hi, Scott. Thank you.
Juanita, can you introduce yourself and tell us about your current role?
Well, I am an electrical engineer working out of the Erlangen office here in Germany. My main role is as an application engineer focusing on protection testing in electrical substations. So I basically get to perform the protection tests right there in the substation with our customers using our products. I have few goals in my job. First, I make sure those protection devices are working properly. Let's say they are like the brain of the power system. Another goal is to see how our products perform in real conditions. We can find out where we can make improvements and bring that feedback to the development team. And lastly, and very important, I see we want to give our colleagues, no matter their department or background, the chance to see our OMICRON devices in action and to visit a real substation. So it is a program that we have here in Erlangen. It is called the Practical Site Experience. And one of my colleagues, Carolina, mentioned about this program in an earlier episode. And so I'm also involved in another nice projects, which are, for example, consulting or development of protection testing templates. So PTTs, we call them in OMICRON.
Juanita, what is involved with developing protection testing templates or PTTs, and how do they help customers?
Developing a protection testing template means creating a testing file that automatically calculates the values to be injected. And those calculations or those new values are based on the relay parameter settings that are given by the user. It helps our customer to save both preparation and execution time, but it also ensures consistency across the teams and improves both the efficiency and quality of the protection tests to be executed.
What gives protection devices the reputation as being the brain of the power system?
Protection devices are seen as the brain of the power system because they receive information, analyze it, and take quick decisions. So they get real-time measurements. They constantly compare those measurements with some relay settings that are the reference, and then they act fast if they have to. So they're always aware of what's happening, and they respond to protect people, equipment, and to keep the lights on. And that's why testing them properly is so important.
Okay, so if they sense a problem, they automatically reroute or shut off the power to particular equipment. Is that correct?
Yeah, for that protected asset. It's not like one protection device will operate and suddenly the whole system will be out, but just a particular asset that is being protected by that device.
Okay, so a substation has several protection devices.
Yeah, many. The biggest substation I've been to had 30. It's quite huge.
Interesting. Juanita, you mentioned giving product feedback to the development team. Can you describe why this is an important aspect of your job?
Yes, because we want to change the world for the better. And today's world is full of challenges, and our customers face those challenges in the field. And only a product that evolves with those challenges can truly help our customer. And that's why giving feedback to the development team is so important. And for me personally, it gives my daily work beyond the protection testing, of course, an extra layer of purpose. And this exchange is, of course, also a win to win. We all learn from each other, and that enriches our work on both sides.
Very good. Juanita, what has inspired you to pursue your field of study?
Well, considering that my whole family works in the health sector, I would say my inspiration was definitely my uncle, who I grew very close to. He's also an electrical engineer, and he was also very passionate about it, and he was always fixing everything. And I think that was my first inspiration. And then when I was in school, I always loved numbers in general, math. I knew I wanted to head in engineering direction, and then I selected electrical engineering. And then when I was near the end of my university, I was in a workshop and I fell in love with protection systems because of their accuracy. So I was really amazed that when I calculated manually an operation time, and then I tested the device using OMICRON devices, by the way, and the relay operated almost exactly at the value I had manually calculated. So I thought, like, wait, wasn't real life supposed to be totally different than what we learned in the university? Was my first thought. And in this case, for me mainly, or for me personally, it was exactly so I learned. So it just caught my attention, and I started in the protection field.
Juanita, you mentioned something interesting. What makes protection testing more of an exact science?
It is all about precision. So in protection testing, we work with exact settings. Sometimes we deal with operation times in milliseconds. And even though there is a lot of math and logic and processing behind the whole protection stuff, when the relay operates exactly as calculated or within a very tiny tolerance, it shows how exact or how closely the theory and practice here align. That level of accuracy is what makes it feel like an exact science. And of course, as a tester, the level of precision also defines whether your test truly addresses that device that you are testing.
Thank you for that explanation. Can you tell us about your career path and what led you to your current role at OMICRON?
I studied electrical engineering in Colombia, focusing on power systems. I worked then for 3 years as a protection engineer in South America. When I was ready to pursue my master's studies, I wanted to do it overseas through a scholarship program between the Colombian government and the German government. To be admitted to that program, I needed to know a second language, so I studied English for a year in Australia. And then I finally moved to Germany to do my master. I was looking for a place for the internship and then for the master thesis, and I found the OMICRON office here in Erlangen. So I applied for the internship position and then continued with my master thesis at OMICRON. And then I stayed in the engineering services team here in Erlangen. And since then, in my current role.
Juanita, how long have you been a protection testing engineer at OMICRON?
For about 3.5 years now.
Which OMICRON solutions do you use for protection testing with customers? Can you describe what each device is used for in the testing process?
So for traditional protection testing, I mainly use the CMC 356. And more recently, since the release, the new CMC 500. These devices act as current and voltage sources to simulate the faults and to measure back the relay's response through its binary inputs, through the binary inputs of the CMCs. And then when it comes to protection testing in digital substations, I also use the Daneo 400 for network analysis. I see this one as my way of checking the electrical drawings before testing. So I can make sure that all the signals I need for my test are available somewhere in the network. Another tool I use very frequently is relay sim test. It is used for system-based protection testing, where the focus is no longer on a single protection device, but on how multiple devices interact under real power system conditions. I use it in both traditional and digital substations. And finally, or additionally, for control and automation testing, I use Station Scout and ID Scout.
Very good. What aspects of your job are you most passionate about?
Well, I would say as a tester, I love finding errors and understanding why they happen and how to fix them. For me, a protection test that runs without any issue or any finding is just kind of boring, let's say. What I enjoy most is then taking those findings to the office and digging into them with my colleagues and finding a solution either for us as a team or for the development of our equipment or for our customer if the problem is in their side, let's say. And we all at the end learn from it together, and that makes my day.
Very good. Could you maybe give us an example when a protection test did not go as planned? How did you resolve the problem and what did you learn from it?
Well, the differential protection tests, they usually don't run that well. Most of the time, I have problems for the stability test of them. And the common issue I often see is with the start direction of the current transformer, either due to the incorrect drawings or because of the swapped CT wiring during installation. What I have learned, especially with that differential function, is to always verify the entire measurement chain, even right down to the exact input connection of the device. Like really how it is written in the manual of the device, it is exactly so connected in the substation.
Can you share some of the highlights of your favorite projects?
Yes, actually, one of my first projects is one of my favorites. It was a new 220 kV substation in Ecuador. I was there with two colleagues from the same company doing all the protection and control commissioning tests, and many other people from other companies were also there executing other activities. It was a very big team, but the three of us were new, and the project was 4 months long. And it had many challenges with the most difficult protection functions, schemes to be tested. And we went through all possible moods during that time. However, at the end of the project, when the transformer was energized and it made its characteristic noise, everyone was instantaneously super happy, hugging and congratulating each other. And that moment stayed with me. Like, it showed me the passion in this field and how a common goal drives us all, and how reaching it let us forget possible bad memories or experiences that we may have had along the way of the project. And of course, in this specific project, since it was very difficult, the learning curve for me was exponential, making it a big jump in my professional development. With the help of the team and persistence, I didn't lose confidence in myself or my team, and we successfully completed the test at the end.
Well, that's certainly inspiring. Juanita, you come from Colombia, and you participated in your first project in Ecuador. Do you spend a lot of time with customers in Central and South America?
Well, these days, I mostly work with customers in Germany. and sometimes across Europe, but I am still in touch with a few customers from South America.
Very good. So as a protection engineer, what are your top 3 or 5 tips for those looking to succeed in your field?
That was a difficult one to answer. I will say first, try to get some hands-on experience right there in the field, in the substation early on. It really helps you to understand how a substation or a power system in general works, but let's say from its construction perspective and how the whole information flows. Then I would say be curious and do not be afraid of trying things out. If something doesn't make sense or you don't understand something, use your testing tools to explore, to inject, and to figure out what does the device when you have that case. And I will also say keep learning by asking questions and sharing knowledge. And most importantly for me, have fun. And if you don't, just change it.
That's a good philosophy. What have you learned the most in the area of protection testing that you would like to share with our listeners?
One of the most important things I've learned is to never assume anything in protection testing. Even if it is a simple setting, check it. That it's so configured as it must be and as you expected. Even small configuration details, I will mention now. Another example is like CT polarity or wiring can lead to major issues that are even more difficult to solve in the future. I always take the time to verify, in this case, the entire measurement chain. That extra attention to the detail at the beginning can save a lot of trouble later on.
Good point. So, Juanita, how does your work contribute to excellence and best practice in the area of protection testing?
I will say ensuring the reliability and safety of the power grid is the main goal of protection testing, and that should always remain the focus, no matter what new technologies or challenges arise. And then in my work, I adapt testing practices to the evolving technologies and demands, or at least I try to do so. And I make sure that core objective never gets lost, the safety of the grid.
Excellent. What do you see as future trends in the area of protection testing?
I like that question. I will say it is already happening. I still see it in the future. It will become even more prominent. Digital substations with centralized control and protection systems, along with wide area protection schemes. I see the first step in this transition as a vendor-specific standalone solution, mainly to gain more experience with engineering, testing procedures, and communication networks. And as a next step, it could be a vendor-independent server using virtualization technology to host different protection and control applications. That would be the evolution of that first step. And I also believe that a stronger standardization and automation of protection testing procedures within the companies will be essential for reaching that level. It is, from my point of view, the only way to manage the increasing number of new substations efficiently but reliably.
Perfect. Juanita, thank you very much for joining me for this episode of Energy Talks to talk about your experience as a protection engineer.
Thank you, Scott. For me, it was a pleasure to be on the Energy Talks, and until next time.
Oh, definitely. I would certainly love to hear about your further experiences in protection testing.
Thank you.
Take care.
You too. Bye-bye.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.